Hello everybody! Today we are going to talk about binary search. Binary search is an easy and effective way to find a number in a sorted array. Well, not necessarily a number, it could be any element in a sorted list of them. Binary search is super effective. In the worst case, it takes only log n time to find the answer. So, let's get started.
As an example, I will use sorted array of integers. Let's say I want to find number 7 in that array using binary search. Step 1. Divide array in halves and get the number in the middle. Division gets rounded to the smaller number, so the middle will be on the left. Step 2. Compare that middle with our target. Is it equal, bigger, or smaller? If it equals, we're done. But in our case, 7 is bigger than 5. It means the target is located somewhere on the right part over here, where all bigger numbers are. It also means that we can forget about all smaller numbers on the left. We stop looking at them. Step 3. Repeat steps 1 and 2 on the remaining part of array till you find the number. It means we divide this part again, get in the middle, comparing, and moving on.
Okay, let's name our variable first. Our middle I will call m. Over here, left value of index is L and the right one is R. How to count the middle? I will use the expression in the red rectangle over here. And the question is, why not to use this one below? Well, from a mathematical point of view, those two are equivalent. And the second one looks easier and simpler to understand. Well, to count the middle, it's like L plus R divided by 2. Well, not use it, because in real life it may cause integer overflow. What do I mean? Well, it fails for large values of L and R. Specifically, it fails if the sum of this is greater than the maximum positive int number. Sum over here is greater than 2 in 31st power minus 1. And if our search repeatedly moves to the right. What do I mean? For example, for larger arrays, when R index equals int max, let's count the middle. M equals L plus R divided by 2. L equals 0 in the first step, so it will be 0 plus int max divided by 2. Everything looks good, but on the second step, when we get rid of the left part, our L will be equals M, and we will need to find a new M. M will be same, L plus R divided by 2. L at this point is int max divided by 2 plus R, which is still int max, and that's when overflow happens. Finally, we got to the coding. I'm going to use recursive implementation because it's easy to understand and I love recursion. For this approach, I will need two methods. First one is the method where I will initialize my variables. Those are left and right indexes. And the second one is a helper method, which will actually do all the work. So let's see. The first one, the method that will return integer, it's the index of the target, if there is one, and I will call it binary search with two arguments, which are array of integers and int target. Good. So let's say we need the left index. It's the very first
index of the array, which is 0, and the R index in the right is the last one, which equals R length minus 1, like that. Let's write a second one. It's a private method because I'm not gonna call it anywhere outside of this class, and it also will return int. I'll call it helper, and this one will have more arguments. Same array, same target, and additionally 2 indexes, left and right. So I will return to the first method and call my helper method. I will return it actually, because helper returns int as well, so we are good. Passing same array, same target, left and right folders. As I already mentioned, the first step is to count the middle. So the middle index equals L plus R minus L divided by 2. Now we need to check if the target is equal to middle. So target equals to, well, not actually to middle, but to the element in the middle, right? If it does, we are returning this index, which is mid. Okay, else, if target is smaller than element in the middle. So if target is located somewhere in the left part, we're calling helper method again with the same array, same target. Now we know the target is in the left part of the array. It means the left index stays the same. It's still 0. So I'm passing L here. And the last index, the index on the right part, is the middle, right? And the last condition left is when target is bigger than the element in the middle. Well, actually I don't need even condition in braces here, because it's the only option that's left. I will just call helper method and pass needed arguments. This time, when the target is in the right part of the array, the L will be middle and R is not gonna change. I guess that's almost it. The only one condition I didn't check here is what if there is no target? What if we will not return anywhere in those conditions? So we need to add one more condition to check. Actually, I'm going to add a while loop and return -1 if there is no target. Let's think about condition in a while loop. When should we stop? Well, whenever array is getting shorter and the borders of the array getting closer to each other, we still could proceed. But whenever left and right met, that means we're done. There is no numbers to check. That is why the condition will be here while L is less or equals R. I put equals for the case when there is only one element in the array, so it will be covered. Okay, I guess that's it. As I already mentioned, in terms of big O notation, it takes only log n time to find the answer, because we're constantly dividing arrays in halves. And one more case I would check here is if array is null or empty. I would return -1 or throw an exception in this case, which makes more sense. So easy to remember this search if you think about some real life task like searching for a name in a phone book. And for example, if you could manage a list that contains all the people in the world sorted by name, you could find any person in less than 35 steps. Pretty cool and fast.
I guess that's it. Thank you.